Hello, I will speak about the building special vectors as a comprehensive way. Well, now I will talk about the basic vector concept. This basic vector concept, one considers a car moving along a curved path. The car's velocity is a vector with magnitude, speed, and direction towards the car's destination. Building special vectors focusing in constructing and understanding specific types of vectors. A comprehensive exploration of the different special vectors and their applications. Well, now it's time for unit vectors. In, in direction indicators indicates how unit vectors provide direction information without specifying distance. Now we use annotation I, J, and K, introducing the standard notation for unit vectors in Cartesian coordinate system. When navigating in a unit vector can represent the direction you need to travel to reach your destination irrespective of the distance. Position vectors. Vectors used to describe the location of a point relative to a reference point. The vector connecting a point to a reference point, representing a point position using a vector notation and coordinate. For example, imagine a drone flying in the sky. Its position can be represented by the position vector x, y, and z, where x, y, and z are the drone's coordinates relative to a reference point of the ground. In a GPS application, a user's current location can be represented by a position vector with latitude, longitude, and altitude values. Displacement vectors. Vectors represent the change in position from one point to another. How displacement vector captures the shift between initial and final positions. It's a motion and transformation, utilizing displacement vectors to understand motion and change in object position. In a physics experiment, a ball dropped from a certain height can be described by the displacement vectors that point from the initial release point to where it hits the ground. Direction vectors. Direction vectors indicating the direction from one point to another, expressing orientation without specifying distance. And there's some uses like navigational and geometric. Real-world application in navigation is geometric analysis. For example, in computer graphics, a camera's direction vector determines where the camera is pointing, influencing the view of the scene. Velocity vectors. Velocity vectors describing the rate of change of position vectors, combining speed and direction information into a single vector. Uh, its dynamic context applying velocity vectors to describe the movement and object in dynamic scenarios. For example, when a spacecraft lands into another planet, its velocity vectors is crucial for ensuring a safe touchdown by controlling speed and direction. Forces vectors representing physical interaction such as pushing or pulling. A strength and direction defining force in terms of their magnitude and direction. Is used in mechanics and engineering. The role of force vectors is understanding the object motion and structural stability. For example, a suspension project stability depends on analyzing force vectors in its various components to ensure they can withstand different loads. Normal vectors are vectors perpendicular to a surface, describing how surfaces interact with light and other objects. It includes graphics and rallies, the application of a normal vector in computer graphics, and visual rallies. For example, in 3D Modeling a normal vector to a polygon surface is used to calculate how light interacts with that surface, affecting its color and shading. Cross product and cross product vectors. A mathematical operation involving a vector perpendicular of two input vectors using geometric interpretation. Understanding the significance of the cross product's direction. And physics, the torque applied to the spinning object can be calculated using the cross product of the force vector and the distance vector from the pivot. For example, if I A vector and B vector are two perpendicular unit vectors, find the vector 3 times A vector minus B vector times minus 2 times A vector plus B vector. We need to do these operations using the distributed principle, where the first term is multiplying by the first term of the second parenthesis, and finally we need to do the sum of the rest from the different terms, and the final, well, the result is minus 7. Special vectors have practical application across various disciplines, from navigation to physics, engineering, and art. Exploring and mastering these concepts empowers us to solve complex problems and create innovative solutions in our respective fields. Reiterate the importance of special vectors in multiple domains. This encourages to further exploration, motivating the audience to delve deeper into the vector mathematics and its application. So this is all for this time, and thank you for listening.